This is the Algebra 1 video lesson for section 10.4, solving radical equations. So we've learned all about radical expressions and how to simplify them with the goal of being able to solve equations with radical expressions in them. So again, when we're solving equations, we're just trying to get x alone, and that will require us simplifying radical expressions in order to get x alone so we can solve the equation. So in this lesson, we'll solve equations containing radicals, and then we'll learn about extraneous solutions. Okay, so let's see this first one. What's the solution to this equation? Square root of x plus 7 equals 16. We'll do our normal, put our brackets around our equal sign, find our x, and then isolate it. Let's subtract this 7 from both sides to get our square root of x by itself. That's the goal first. You want to get that square root of x by itself, or the radical by itself, or whatever the radical, if it's around the x by itself, so that you can square it to get rid of it. 16 minus 7 is 9. And then to undo a square root sign, remember we square. So the square root squared is just what they cancel each other out basically. So whatever's inside is just there by itself. So we have to do that to the right side as well. We'll square the 9. So then this just becomes x. Square root of x squared just becomes x, and 9 squared is 81. Okay, and then you can always just check. The square root of 81 is 9 plus 7 is 16. So that matches with this here. So that works. Okay, so try this one on your own. Get x by itself for your solution, and then after you push pause, check back for the solution. Okay, hopefully you got x equals 9. I just add 5 to both sides and then square both sides. And then if you plug 9 in here, square root of 9 is 3 minus 5 is negative 2. So you can see that that works. Okay, so let's see. We're going to skip the word problems. I skipped them in the homework, so I just don't think the best thing to do right now with this material. So we're just going to, we'll skip that too. Solve equations. Okay. So here is another equation. It's getting a little bit more complicated. We have square roots on both sides. So when we square both sides, the square roots just go away. So really, we're just looking at the inside. So if the square root of this equals the square root of this, then whatever's on the inside have to be equal. So the square roots cancel. So we just get 5t minus 11 equals t plus 5. And then we just get our t alone. We have t on both sides, so we have to subtract this. Oh, that's not a pencil. Subtract t from both sides, and we end up with 4t minus 11 equals 5. And so then we add 11 to both sides, and we get 4t equals 16. And then we can divide by 4 on both sides, and then t equals 4. And then we can just plug that in. 5 times 4 minus 11 is 20 minus 11. That's the square root of that. Just doing this, I just plugged in 4 there. That's the square root of 9. And then this side is question mark. Do these equal each other? 4 plus 5, that does equal the square root of 9. So that works. Okay, so try this one on your own. Press pause and then check back for the solution. Okay, so the answer here is x is 7. When you square both sides, subtract 5x from both sides, and then add 4 to both sides. Get 2x divided by 2, you get 7. Plug in 7 here. 7 times 7 is 49 minus 4 is 45. So the square root of 45, does that equal 7 times 5, which is 35 plus 10? Also 45. So that works. Okay, and then a little note here. An extraneous solution is an apparent solution. So it looks like it's a solution, but it doesn't actually work. It doesn't satisfy the original equation. So this happens when you square both sides, but if it's not a square root, you square an x, it actually gives another solution that would work. Because of when you take the square root, you get the positive and the negative, but that doesn't actually solve. So I'll show you what this means in the next example. Here you can see we have a square root on one side, but the n on the other. So when we take this, square both sides here to get rid of this square root, this side becomes n plus 12, but then this becomes n squared. And remember when you have, actually I don't know if we said this or not. I don't think you learned this until Algebra 2. So I won't even confuse you with that, so never mind. We have since this is quadratic, we have to get it into the quadratic formula, which we learned, quadratic equation, which we learned in the last chapter. So whenever we have this x squared, we want to make one of our sides 0 so that we can solve the quadratic equation with one of the methods we learned in last section. So since the n squared is on this side and it's positive, we want to move everything to this side. So we're going to subtract the n and subtract the 12 from both sides. So then this becomes n squared minus n minus 12 equals 0, because this cancels and this cancels. So now we have our quadratic equation. We're not graphing, the b is not 0, so we're going to be trying factoring first. So 1 times negative 12 is negative 12, and b is negative 1. So we need two numbers that multiply to negative 12 and add to negative 1. That's negative 4 and 3. So we can use our shortcut and just go n minus 4, n plus 3, since my a is 1 here. And then that would be 0 if n was 4, and that would be 0 if n was negative 3. So now we have two solutions, but only one of them works to solve the original equation. And you don't know that until you check, but this is n equals the square root of n plus 12. When you have a square root of a number, it's never negative. So this n cannot be negative. So that means this answer is not going to work. This is going to be my extraneous solution. So if you see that, you can just go right there and say, look, this is equals n, and my n here is negative. It's not going to work. But what you should do also is just plug it in to double check. Does negative 3 equal the square root of negative 3 plus 12? Let's see. Negative 3 plus 12 is 9. And the square root of 9 is 3. That does not equal negative 3. So this is not a solution. So that means this is going to be our only solution, and you can double check that that works by plugging in 4. Does 4 plus 12, the square root of that is 16. Square root of 16 is 4. So 4 does equal 4. So this is my solution here. It's just n equals 4. It's not n equals negative 3. Okay, so try this red star one on your own. Press pause and check back for the solution. Okay, so here the solution is x equals negative 2. Right, and that's because if you plug in negative 2 here, it makes it a negative and turns it positive under the square root. So that's why it's not always the negative one that's the extraneous solution. So you do need to check. So here when we squared both sides, we got y plus 6 equals y squared. So we subtracted the y, subtracted the 6, did some factoring, and then got our two solutions. Found that this one was extraneous because when you plugged in 3, you got negative 3, and you cannot have a square root that equals a negative number. And negative 2 worked. So that was our solution. Okay, and now problem 5, the last problem we'll work on here. Let's get y by itself in this problem. So we are going to subtract 8 from both sides. You see that square root of 3y equals negative 6. We can already see we're not going to have a solution here, right? Because the square root of a number equals the square root needs to be positive, and this is negative. So watch what happens here. We square both sides. This becomes 3y, and this becomes 36. And when we divide by 3, we get y equals 12. But when we check our solution, so you should always be checking, 3 times 12, square root plus 8, does that equal 2? This is 36, the square root of 36 plus 8, that's 6. 6 plus 8 equals 14. It does not equal 2. Okay, so this doesn't work. So this is an extraneous solution. And so that means the answer is, there's no other number to try, so the answer is no solution here. Okay, and we knew that back here when we saw that we had a square root equaling a negative number. That could never happen, but we do need to show that that is y. So why don't you guys try this one? Oops, trying to do this here. Try this one, press pause and check back for the solution. Okay. So when I moved this root 2x over on this side and subtracted the 10, we got negative 4. You cannot have a square root that equals a negative number. So I just stopped there. I know I just said you have to show all the algebra. But if you know why the square root cannot equal a negative number, if this is a negative variable, that would work, right? Because you could plug in a negative variable and then that would change the sign so it would turn positive. But since this is a negative number, that can't be changed, and that doesn't change, and so you can have a square root. I just stopped there and said this is not possible, so there's no solution to this. If you did continue on and square both sides, you would have got 16 equals, oops, not that, 2x, and then divide by 2, you would have got x equals 8. And then if you plugged 8 in, 8 times 2 is 16, 6 minus 4 is 2. That's not equal to 10, so you would have seen that that was extraneous. Okay, that's it. Enjoy.